morning, everyone. My name is Abi Wakama from IT News Africa. And thank you for joining us on day 2 of IoT Forum Africa. To our eminent speakers, exhibitors, sponsors, and delegates, I bid you a warm welcome to today's proceedings. We are indeed honored to have you here with us. Today, we will focus on deriving practical benefits from IoT, and our speakers will cover a number of important topics, including monetizing or profiting from IoT, unlocking business value from IoT, solving Africa's issues with IoT, and the ethical and legal concerns around the Internet of Things. And before I hand over to the first speaker for today, I would like to take the opportunity to thank our lead sponsor, Squidnet, for throwing their weight behind this event. And without further ado, let's get into the first presentation. The first speaker is Thomas Nicholls, and he's the Director of Communications at Sigfox. As a frequent speaker at international IoT conferences, Thomas blends his expertise in cellular connectivity and embedded software with his excitement about IoT's promise to positively change virtually all aspects of life. Please welcome Thomas with a rousing round of applause. Thank you.
Good morning, everyone. Thank you for being here so early. Hope you've had a cup of coffee. So today we're going to be talking about the business aspects of the IoT. We're going to talk about how it can be used in Africa and in South Africa. What I would like to share with you is my vision of what the IoT is actually all about. Because I spend way too much of my time traveling around the world, speaking and listening to people speaking at events about the IoT. Everyone talks about the IoT. But I think we're forgetting why we're actually doing this and what it's all about. And that's what I wanted to share with you here today. So, when I was a child, I wanted to be like Superman. I don't know whether I'm the only one, maybe I am, and then it'll end up being a bit embarrassing, but I'm sure that many of you, also when you were kids, wanted to be like Superman or Superwoman. For many reasons, probably because they were strong, they could fly, and all sorts of cool things. But the reason why I was so fascinated by Superman was because he knew what was happening in the world around him, even far away. He could hear when someone was in distress. When an accident was about to happen, he would know it, and he would fly out the window, and he would go and save the beautiful woman and the kids in the car and whatever. So I was deeply fascinated by this ability to see through walls and just know what was happening around us in the world so that we could be more efficient and save people and do all sorts of cool things. For me, that's what the IoT is about. The IoT is about basically making all of us into superwomen and supermen by giving us insights into what is happening in the physical world around us. The IoT for me is not about gadgets. Sure, there are some gadgets, I own some, but the real IoT is about the data, the insights we can get on what's happening in the physical world, so that we can make smarter decisions, and so that we can create new services that make our lives better. So this means that either we need to come up with a way of becoming Superwoman and Superman, but I don't have the magical solution for that, sadly. I'm sorry about that. But what we can do is that we can try to come up with a solution of getting the same insights as Superman and Superwoman has, meaning that we can deploy sensors in the physical world that can tell us what's happening. That can tell us what's happening in the things and around the things where we've put the sensors, so that we get that knowledge, that data on what's happening, so that we can make decisions based upon what's happening in the physical world. So this is all about digitizing what is happening in the physical world. Now, digitization is nothing new. It's an era that we've been in for a long time. You've all seen what's happened to music. Many years ago, you would have to go to some place where there was a great musician to actually listen to music. Then we started digitizing music. We got LPs, CDs. We've got streaming services. It has completely disrupted how we consume music. We've also seen digitization moving into the physical world. The biggest deployment of physical sensors that we have today is mobile phones. So we all have mobile phones, smartphones, feature phones, all sorts of phones. And those phones have sensors in them. So by owning a mobile phone, you're actually kind of a Superman already today, or Superwoman, so you can already be happy by that. And what they allow us to do is create new services based on these insights that we get from having sensors on people all over the world. One example is navigation. So when you're driving, or if you're lost when you're walking in a new city you don't know, then you can pull up Google Maps or Waze or some other service that can tell you how to get to your destination. You even have services such as Waze and Google Maps that use all of the data from all of the users to detect where there's a lot of traffic, so that they can guide you around those obstacles so you can get to your destination much quicker. All of that is based on insights on what is happening in the physical world. Now, as soon as we get data on what's happening in the physical world and we pull that into the cloud, then we can use all of those tools that we already master so well, which are mobile applications and web applications that allow us to crunch that data and send alerts to people through text messages or through fancy interfaces. We've got all of the data algorithms that allow us to crunch historical data, to even do predictions and say, when something is happening in the physical world, we know that whenever that happens, 1 week later, the thing breaks down. Say that the projector projecting in here all of a sudden starts to move a bit slower. It will still work, but the engine starts to slow down because maybe it's getting old, the projector. Then if we have historical data on all of those projectors, we will know that in exactly 1 week's time, the projector will break down. So we can use all of that data to do predictions. But the thing is, mobile phones are great, and mobile networks are great. But if we want to truly become Superwoman and Superman, we need a way to have many more sensors, all sorts of small, simple to install, simple to maintain sensors all around us. And that's not something we can do with traditional networks and traditional means of connecting things. Because traditional means of connecting things were all built for high bandwidth, multimedia style connectivity. And when you do complex connectivity, the devices, the sensor devices, need to be complex. They need to manage complicated communication protocols. And when you talk about complicated connectivity, it means a lot of processing on the device, which means a lot of energy consumption, and which means that the silicon you need in the device needs to be rather sophisticated and therefore rather expensive. So the cost and the energy consumption really limits the amount of sensors we can put out there. So we need a new way of doing that. The biggest obstacle in reality is energy consumption. You all know that you have to charge your phone very often. If you have a feature phone, it's a bit less often. I miss when I had a feature phone. A smartphone needs to be charged once a day, sometimes more. And obviously, if we want to have sensors all around us in the physical world, that just doesn't work. We need to have something that can last for years to decades on batteries, so that we have much less maintenance to do. And ideally, and that is actually something that is beginning to happen now, we need to avoid chemical batteries altogether. And I don't know how many of you know about energy harvesting. Have you heard about energy harvesting? Yeah? Energy harvesting is all about using the different energy sources that we already have around us to collect energy, enough energy to, for instance, send data. So today, it's possible to use solar panels, to use natural light, to gather enough energy to send data. We can also use panels to collect energy from artificial lights. So if you have something inside a building, you can actually collect enough energy to send data. You can even use things, and that's something I personally just learned not that long ago, and I find that pretty cool. You can actually use the temperature difference between your body and the atmosphere, the air around you. That temperature difference is enough to generate energy. So that means that we are close to a world where things like fitness trackers and all sorts of sensors don't need chemical batteries at all. So we are breaking down the barriers of energy consumption. The cost of devices is critical. The cheaper it is to create a sensor device, the more sensor devices we can get out there. The more business models will work. You won't be able to create a business model based on predicting when a projector will break down if it will cost you 50 bucks. But if it will cost you just a few bucks, then you probably can make a business out of that. So the lower the cost, the more business cases we enable. Now, the thing is, sadly, there isn't a lot of magic when it comes to connectivity and radio communications, because we're all governed by the laws of physics. So if you want to really be able to pick up messages sent with very little energy from very simple sensor devices, then you need a very different type of network. And that's what we set out to do at Sigfox. We set out to create a network that was not there to compete with existing networks, but a network that can only handle very small exchanges of data. Very, very simple messages. What's the temperature? How many times has the engine been running within a projector? Where is an animal located? Where is a car located? Simple messages. But by compromising on the type of data we can receive and send, we can build a very different type of network. Now, we didn't actually look to telecommunications networks to come up with how we could build this network. We actually looked at something very different. We needed something that allowed us to collect data from sensor-based devices that is so simple that the devices don't need to know about the network. It needs to be as simple as car keys. The keys you have that allow you to remotely open or lock and unlock your car, they can run for years on batteries, right? They don't have that same problem we have with our mobile phones. Why? Because they don't manage complex protocols. They have a dead simple radio chip inside them that just emits a radio signal, and then the car has an ear that listens, and when it picks up that message, it unlocks or locks the car. So in order to build a network that is deployed as a telecommunications network, meaning that it's antennas on rooftops and on masts, but that is sophisticated enough to pick up, to listen and pick up these messages sent with very little energy, then we looked at what astrophysicists do. Because if you think about it, astrophysicists, what they do, the challenge they have, is to listen to the cosmos, listen to all of the noise coming from space, and then send all of that noise to some sophisticated software that can go through all of that noise and try to find interesting noise, interesting things, data that we can use to gain insights on what's happening in the space around us. And they obviously can't walk around putting mobile phones on all stars and everything in the cosmos. They just have to be really, really good at listening and really sophisticated when it comes to crunching all of that noise that they listen to. Now, the thing is, radio telescopes are extremely expensive. But they've actually learned, the astrophysicists, over the years of listening to the cosmos, that a smarter way of doing it and a more efficient way of doing it is not to have a few very sophisticated radio telescopes. It's to have what they call a large array of small, cheap, simple radio telescopes that all listen to the same thing. They all listen to space. and they all send the noise that they listen to software. And that software will aggregate all of the noise and will then crunch the data. And when you have many radio telescopes, your ear becomes much more sophisticated. I have come up with a way that I think is quite simple when it comes to explaining the advantage of doing this without going into the technical aspects. Imagine that you're at a dinner party. You're sitting at a long table, lots of people sitting at the table. Someone in the middle of the table is speaking. Now, if you're unlucky enough to have other people speaking sitting just next to you, there's a big chance that you won't be able to hear what the person sitting in the middle of the table is saying. But now imagine that 5 random people around the table were all listening to the same thing. Then there's a big chance that at least one of those people would pick up what's being said by the man sitting in the middle of the table. That's the same concept that astrophysicists are using. They're saying maybe one radio telescope won't pick up the important message, but if we have many different radio telescopes, then there's a much bigger chance it will pick up all of the interesting data. So we were inspired by this way of doing connectivity because it's the only way of really simplifying the sensors. By not creating connections between the network and the sensors, just having a very sophisticated ear. And then pushing all of that noise, which is just radio noise, into software that can then crunch and go through all of that noise and look for the interesting messages coming from those sensors that send data that we want to pick up. This type of connectivity needs to be available everywhere. We believe that the Internet of Things is not about borders, it's not about boundaries. It needs to be a new capability that we have that allows all of us to be superwomen and supermen, no matter where there's a need for us. If we only cover cities, for instance, then we cover a very small part of the use cases. This is something that should be available to everyone and everywhere. So we have set out to roll out a network globally. And when we say globally, we're dead serious about it. We mean globally. Today we are rolling out terrestrial, but we've already done the first tests on adding satellite coverage as well. The goal for us is to provide truly global, simple connectivity. We started rolling out the network in 2012. And since this network is based on very simple antennas, we can roll it out very quickly. So today the network is present in 32 countries. It's the quickest network rollout ever. We are rolling out with our partner Squidnet here in South Africa. So I hope you were lucky enough to get the presentation from Squidnet yesterday. And do drop by their booth to learn more about Sigfox and what they're doing in South Africa. So we're rolling out this one single big ear all over the world. One other thing that makes this network very different from traditional connectivity solutions is that it's one single ear. It's not different operators in different countries rolling out their own network and then trying to provide roaming agreements so that you can do stuff across borders. No, this is one single ear. Which also means that if a brilliant company from Johannesburg comes up with a great device or a great application, then that same application can be deployed anywhere in the world. So it's one network, one global ear. So today we're in 32 countries. At the end of this year, we'll be in more than 40 countries. At the end of next year, in more than 60 countries. So it's going to be a very, very fast global network rollout. And the applications that we see connecting to our network, today we have more than between 10 and 15 million sensors sending data over our network today. And it's all sorts of different applications within all industry sectors. We've got, not that far from here in Zimbabwe, we've got some rhinos that are connected. So basically, the rhinos, they send data. They send an alert whenever there's stress. If the animal starts to have movements that we can detect as being stress symptoms, then the location of the animal is sent so that people can be sent out to find what is most likely poachers in the area. But we also have, of course, industrial applications, more commercial applications. For instance, leak detection on water pipes, or it can be security systems to find stolen vehicles. Now, you might say stolen vehicles is something that is not that new. And you're right. But stolen vehicle recovery, for instance, has been reserved to some types of use cases and business cases. What we think is that everything should be able to be located if it's stolen. What about motorbikes? What about bicycles? What about knowing whether my kid has left her school at a time when she wasn't supposed to leave her school so that I can locate her? We want to give those capabilities to everyone and to everything. Now, when we started out, in all honesty, a lot of the traditional mobile network operators thought that we were in this business to compete with them. But I can reassure you, on our network, you can't use your mobile phone. You can't go on the internet. It's a completely different type of network. And what we've actually discovered is that there are a lot of use cases where traditional mobile network operators combine traditional networks with Sigfox to create new use cases. For instance, within the world of security, a lot of alarm systems are based on cellular connectivity. But today, you can buy a GSM jammer for about $10. And you can basically take out an entire security system using this small GSM jammer. But if you add Sigfox to that security system, it all of a sudden becomes very, very difficult to jam that alarm system. Or you can have a system that, for instance, is used to just detect, for instance, whether something is stolen or not. If it's not stolen, you don't need to get real-time data, but you just need to be able to activate, if it is stolen, a real-time tracking connectivity. So you might have cellular connectivity that is basically sleeping, and then you use Sigfox as a means to wake up a cellular modem to start to get real-time data. So we're discovering a lot of new use cases. Sigfox as a network is completely agnostic when it comes to applications. We are, quote unquote, just a dump pipe. We just transport data efficiently. And then we work with everyone who builds applications. So we are discovering every day. And we are talking a lot to the business analysts, the gardener, the forester, because as you know, they have said that we'll have billions of devices tomorrow, but they don't actually know what those devices will be. So we feed them with all sorts of data about what's happening. And it's funny to see because often when they give examples of why the IoT is very different, they give examples of applications running on our network. So that was it. So please do reach out, come by the Squidnet booth if you want more information or contact me. I would be more than happy to talk to you about interesting ideas that you might have around the IoT. Thank you.
Thank you. Thank you, Thomas.